Okay, so thanks so much, Jason, for telling the first part of the story, which is what brings us here together. But the second part of the story is equally interesting, which is why am I here? Why is Dr. Vinjamur here? What is it that we needed to work together on? And so we're of a generation, Jason and I, in which we each know one part of the puzzle. But we have three speakers later in the day who are growing up in a new generation in which they know both sides of the puzzle, and I think this is what you should be aspiring to. So I want to tell you the story that I went through. One night at 9 o'clock at night, a lawyer walked into my office at the University of Maryland, this fellow right here, and he told me he had a problem. When a lawyer walks into your office at 9 o'clock at night and tells you he has a problem, you may well have a problem too. And so I paid attention, and his problem was the problem he put up the picture of, which was all of this Clinton administration email, and how do we know what we found? But the more important question, how do we know what we haven't found? And what I do is I build search engines, and so I found that to be an interesting question, and I found this to be an application that was different from the sort of search engines that are involved in Google, and so that's the story I want to tell. So I teach in the information school at the University of Maryland in the computer science department and in the applied math and scientific computing program, and so this is what the world looks like from that side. Now, it's all fairly straightforward. We're going to do this in two parts. We're going to have basic stuff this morning, more advanced stuff this afternoon. So I just want to walk through the basics of what the world looks like from my view. In a court case, there is some set of documents. There is some knowledge in the lawyer's mind, and there will be, in the end, some coding of these documents. Now, as Jason described, we want to find out which documents are relevant, which documents among the relevant documents are privileged, and so that's simply a matter of putting documents into categories. And we have technology for putting documents into categories. We call it classification in computer science, but there's a even earlier technology in the law. So the question is, what goes in the black box? And the traditional answer is the lawyer. Right? And so step one, the early days, Cro-Magnon man was you had these large sets of documents that had to be looked through. They were looked through on paper. You got the boxes from the file room, and you just looked through them on paper. But we now are able to come up with better ways of doing this. And so the second way that Jason described is that we build simple representations. What words are in the documents? We have very simple interaction. The lawyer tells us which words to look for. And we have very simple search engines where we simply look for those words in those documents, and this technique was called keyword search, and then the things that came back from the keyword search we did linear review on. And this made perfect sense to the lawyers because lawyers had always done this. You didn't pull every box from the file room, you pulled some boxes from the file room. You pulled the boxes that involved the people, the boxes that were appropriate to the dates for the matter that was being considered, and so just having one other selector, which is the words, made perfect sense. But it doesn't work very well because words have many meanings, and there could be many words that have the same meaning. And it's hard to anticipate the effects of those in a large collection, and so as a result, we now have a more sophisticated technology. So we have better representations, we have better reasoning systems, and importantly, we still have the lawyer inside the box. But now the lawyer is driving a system that is iteratively trying to define the definition of what we are looking for. And so we're taking the knowledge from the lawyer and we're using it inside the box to drive the process. So it's these three things. At every level, it's always been these three things that are the three things that we have to understand in order to make it work. And so this is the current approach. is for taking large collections of unprocessed documents and coding them. So I want to go through those three parts. So what are the representations? Well, fairly obviously, the representations include what's in the content. Now, this is not just what words are in the content. It's what character sequences are in the content, because we might have many different words that have similar character sequences, and so we don't have to search in the same way that people think. We search in ways that are accessible to machines. It's the context. It's who said what to whom, when did they say it, right? So we can see, for example, in email who's on the senders, who's on the recipients. You can look in a thread and you can see when someone gets removed from a thread. There are all kinds of features like that. These would be very hard for somebody to say, oh yes, set the features this way, right? You might imagine you could do that for the words and you wouldn't be right, but it's even harder when you start to get to these contextual factors. Then there's also description. So I might have some information object and somebody might say something about it. So I might have some document, it's an attachment on an email, and I have the email that describes the document, right? And so we don't have to just look inside it, we can look at other things and see what's talking about it. And then what's really the 21st century, what really makes search engines work, is that we can then look at how people behave with respect to this content. Who read the content? When did they read the content? What did they do after they read the content, right? If they read something and forwarded it to somebody else, that somebody else printed it out and then 3 days later wrote an email in which they referred to it, that tells us something about it. And these things would be very hard to describe how we should do this by turning knobs in some search engine, right? So the first thing we do is we get these complex representations, and then we have to find some way to control them. Okay, the second thing is we have ways of computing on these. So we can recognize that two documents are similar because they contain the same words, or two documents are similar because people behaved in a similar way, or two documents were similar because they were described similarly. So we can build systems that do things that are much more sophisticated than simply ask the question, does this system have these words in it? But the problem is still this more powerful way of recognizing what is related to what you're looking for requires you have some way of expressing what you want. And this was the real advance. The shift was from, instead of saying that I want documents that contain these words or that were sent at this time, we say, I have documents that are what I was looking for, and I want you to find more like these. This is an example-based search. And then when you find more like these, then we can find even more like those. But it doesn't work on just one side. You also have to say, this, which looks like what I was looking for, isn't what I was looking for. So the human takes documents and puts them in two piles. And you know, it's like the way we teach our children. If you want a child to behave the way you do, you show them how to behave. Right? And that's what we're doing with machines these days. So these are machines that learn from observing human behavior. I hate it when we call this artificial intelligence. There's no intelligence whatsoever in the darn machine. It's a minor bird. It repeats what it hears, right? But the machines can recognize patterns, and so if we show it examples, they recognize patterns in those examples, and that turns out to be an exceptionally powerful way to do it. The problem is we have to start out by finding some examples. Well, how do we do that? We do it the old way. We use keywords, or we randomly select if examples are common. So it's not that one replaces the other. It's that these things are built on top of each other. Okay, now Jason put up this slide, and he told you that this slide was the most important thing you had to understand if you came here today, right? You were supposed to Google this if you were a student. I don't think that's true, because in my world, I don't care about any of this stuff. Can you go back one? Sorry, touched it. Okay. I only care about that one right there, which is review. My entire world is one part of your world. Lawyers are integrative thinkers. They have to remember all the pieces that are moving. Engineers are reductionist thinkers. If we can't solve a problem, what we do is we break it up into other problems. And if we can't solve those, we break them up more. And after a while, the problems are so simple that we can solve it, and boy, do we look smart because we solved the problem. But we actually solved a problem that anybody could have solved if you're a reductionist thinker. So you have to master both ways of thinking, and here's the way I see the problem. Somebody asks for what they want. We don't do this. We go find it. We check to see if it's relevant. We check to see if the relevant things are privileged. We give it to the other side, and they have to figure out what to do with it. They have to make sense of what we gave them. And so all we have to do is make the three things that go in that box, and we look smart. Right? And so we take this one box that looks like a little piece of some big problem, and we make it into boxes that are simpler, and then boxes that are simpler. And so this afternoon, we'll talk to you about how we do the review for relevance, the review for privilege, and how we do those two things as part of a unified process. Right? So this is just a short picture of the way we think. Now I'll go through this briefly. Lord Kelvin is quoted as having said, if you can't measure it, you can't improve it. And so if you want to know how well your system is doing and when you can stop, you have to have some way of measuring what you're doing. And this is the text retrieval conference that Jason spoke of, where we were working out an evaluation design that can be used to measure how well this works. And I'll give you just one example in which we are measuring these two things together, the machine and the process that people use to use that machine. Right. So it was a bit of a complex approach where lawyers contributed their time to create the artificial legal documents for a court case that didn't exist. They were the funniest darn things in the world. We had people claiming that there were pigeon deaths that were resulting from tobacco. So the pigeons in the park were keeling over because of secondhand tobacco smoke. In any case, there were some more serious ones than that. Then we build the classifiers. This is done by the teams. So the coordinators of the legal track were building these test cases. Then the teams would go build classification systems. The coordinators would pick some documents out and have an expert judge them. And then if the expert was not all that expert and got it wrong, the teams would have a chance to appeal it, and then those appeals would be used to make the final judgments. And I'll show you the effect. Now, we made only one mistake when we did this. Our initial experts were law students. How many law students here? Very good. So the law students were doing this as pro bono work as part of their preparation for working in the law. And their alternative, if they didn't do this, was that they could go defend some murderer or something like that in a murder case. And so this was attractive work because you didn't have to dress up nice. You could sit in your dorm room and just push yes and no, sip a little Merlot while you were doing it perhaps. And as a result, we didn't always get the most accurate results from the law students. But we had a senior attorney who would review their results if there was an appeal from one of the teams. Now, these were the initial results from the teams, and the number here is the number we care about, which is what fraction of the documents that were supposed to be found as relevant in this case actually got found. And you can see that there were a couple of teams for a couple of topics of production requests that were able to do this at 70%. And this was our typical way of doing things. But the lawyers came along and said, you know, we don't actually trust the reviewers. We have some process to check the reviewers. And so we implemented a process like that. And after we did, the results got better. So these are the same systems, the same results, except now judged based on the appeals. And you can see that we have systems that are performing at 85% on this measure of how much did we find, this measure that we call recall. And if you look at the improvements, these are connecting the dots between the original and the improvement. You can see that this process was important. We didn't know how to do this when we started. Lawyers taught us this. And so this is the key message I want you to take away. People like us are odd in this room, right? We don't often talk here. Lawyers mostly talk. But you really need a team that includes people who know technology and people who know the law if you're going to work on problems like this. Okay, this is the very end. This was actually the most impressive thing to me. Lawyers have a way of thinking in which they don't actually care if it's right. What they care about is whether it was a reasonable process that was followed. And so you can ask the question in Cro-Magnon Man when we just had the lawyers inside the box, did we follow a reasonable process? And the answer was, well, did you put a reasonable lawyer in the box? Did you train them reasonably? Did you look over their shoulder appropriately, right? But then later when we got to keywords, you would ask different questions like, well, did you pick the right words in the document to index in the first place? I mean, if you index the and a and an, you're not going to find very much. So did you index it correctly? Did you build the queries using a reasonable process so that you had a reasonable expectation that you were going to find things? Could you explain to someone else how you did that? And did you check to see what you were missing? This was the question Jason talked about. So when you change the technology, you change the definition of reasonable. And if the goal in the law is to do that which is reasonable, you can only answer that question in the context of the technology. And so if we ask what's reasonable in this world of technology-assisted review, the question is, do you have an appropriately rich representation? Is your representation capable of representing things in ways that make it possible to find them? The second is, do you have some process for interaction that uses explicit queries to get started and example-based interaction to become more comprehensive and more precise? And do you have some way of measuring not just how well you're doing, but what the quality of the process you're applying is? So for example, there's a ISO standard, ISO 9000, for measuring process quality, and you can answer the question, did we use an appropriate process to employ the technology? So that's my last slide.